Welcome to part 3 in the 10 things you need to know about infrared inspection windows webinar series. This particular one deals with a rather complex subject of emissivity and why it's important to thermographers to really understand the effects of emissivity on their temperature readings. So what is emissivity? Well, emissivity is the property of a material that relates to how well the material radiates infrared energy when compared to a perfect emitter or something called a black body that is running at the same temperature. So when you look at electrical equipment, it gets very, very difficult because there are so many different emissivities within an electrical cabinet. They can range from anywhere from 0.95, which is on the cable sheathing, down to 0.015 on highly polished aluminum surfaces or copper surfaces. And they're very, very difficult to inspect unless you get an understanding of how this does affect your temperature readings. So looking at some infrared science, we have something called Kirchhoff's law. And what Kirchhoff's law is, it says basically the sum of all the radiation leaving the surface of an object is equal to 1. So when you look at that, if you look at the surface of an object, that means the emitted radiation, the transmitted radiation, and the reflected radiation will all equal 1. Okay, so that's an important thing to understand. Now, when we look at different materials, opaque objects do not transmit infrared energy. So basically then we can look at the emitted and reflected energy plus T, which will equal 0 transmission. Infrared windows transmit infrared energy, but opaque objects don't. The infrared energy does not transmit through them, so that will equal 0. So there's an important relationship with the emissivity plus the reflection then equals 1. So basically, whatever you do to one will affect the other. They're basically linked. So if I increase emissivity, I decrease reflection. If I decrease emissivity, I increase reflection. So it's an important relationship that you need to understand when you start getting into infrared measurement. And again, it underpins why it's very important to do your training, because these things are covered in much more depth. I'm just giving you an overview of the importance of these things. So looking inside an electrical cabinet, so it's imperative that the thermographer knows the emissivity of the target components they're inspecting. So if you look at this is a typical inside of a bus section in an electrical switchgear. If we look at the infrared image, we can see that basically it looks like we've got temperature differences, but this image shows a non-energized bus bar assembly with apparent temperature differences. This is actually in manufacture, so it's never been turned on. So if you look at the electrical tape that's on the infrared image, you can see there I have a reading of 24.6, but the bus bar section here, the shiny bus, looks much cooler. That's because it's reflecting a background temperature. So we're seeing here there's a difference of 4.5 degrees on something that's never been switched on the same length of bus. So very important to understand that relationship. And that all of these temperature differences really are caused by different materials, different reflections, the background temperatures, etc. So here is an experiment that we do during training. We're trying to understand how temperature is affected by background temperature and reflection, etc. So here I have 3 aluminum cans, very shiny. First one here has hot water, second one has ambient water at ambient temperature, and the third one has cold water. Now this is black electrical tape, which is non-reflective, and thermographers get to know very quickly that black electrical tape has an emissivity of 0.95 approximately. So we use that when we're trying to measure temperatures off of very shiny surfaces. So when we look at the infrared image, you can see here that the tape looks much warmer than the can, because the can is reflecting the colder background temperature. If I look at the tape on the can that's at ambient, we have what's called equilibrium, i.e. it's all at the same temperature. But important to note, the can here on the left hand side is reflecting the warmer can that's on its left, and the here on the right hand side is reflecting the colder can. Now if I look at the colder can, which has cold water, the actual tape looks cooler than the actual body of the can, and that's because the can is being apparently warmed by the reflection of the background temperature, which is warmer than the actual fluid that's in the can. So all that you start to see that it becomes imperative that you understand that what you're seeing in the camera and the emissivity of the materials and the way it's being affected by the reflection of background temperatures, etc. You can make a really bad call if you don't know what you're doing. So I'm going to look at this graph here, and this graph shows that basically I've taken this image, and you can do this in your infrared software or even on your camera, and I have an emissivity of 0.95 here. I've changed the emissivity all the way down to 0.5 on the same image, and you can see just how much the temperature is affected. From 0.95 to 0.5, the temperature change is 12.2 degrees. Yeah, 12.2 degrees. So that's gone from 39.1 to 51.3. So when you're using temperature as your mechanism for calculating working out when your maintenance is due, it's important that you understand that the temperature is correct before you make a bad call. So when we now got to understand like reflection, we spoke about, like when I looked at Kirchhoff's law a few slides ago, we showed that reflection and emissivity are inversely linked. So whatever I do to one affects the other. So when we look at reflected temperature, this parameter is used inside the camera to compensate for radiation reflected from the object and that's emitted from the atmosphere between the camera and background objects, etc. So if you look at this infrared image here is basically a thermographer standing in front of a whiteboard. Okay, so whiteboards will reflect back energy quite significantly, as you can see here. You can clearly see the outline of the thermographer, the camera, the glasses, even the ring here reflects back and the watch all reflect back at different temperatures. So if an object emissivity is low, and the object temperature is relatively close to ambient, it will be even more important to set compensation for the reflected temperature correctly. Me trying to measure the temperature of this whiteboard with my reflection in there would be impossible. I would have to have someone in there with a known background. I'd need to know the background temperature, I need to know the emissivity of the material, or I standardise. So the way we can do that is by trying to compensate for how emissivity is affecting our image. So how do we compensate for emissivity and reflection? As I stated, shiny surfaces are extremely difficult to measure, because of their low emissivities and the highly polished surfaces. And those highly polished surfaces are affected significantly by background temperature. So we use things like high emissivity target markers, the electrical tape I spoke about earlier, because they give us a non-reflective temperature with a known emissivity. So looking at this infrared image here, I can see that these tags here are the IRIS IRD label systems where we actually write joint temperatures, etc. And you can see in the infrared image they're quite clear. But point to note also, you see the danger 415 volt tapes, these plastic labels, all of these are non-reflective or minimal reflective with good emissivities. So even if you don't have ID labels, you can take temperature measurements off of these. Here you can see that on the torque bolts there's a label on there. I can take my temperature readings from these and be quite happy with the readings I'm seeing. So, again, another good thing about emissivity targets like these, for instance, they give a known reference point for maintenance engineers that might have to come back and do the repairs after you finish your inspection. So in summary, emissivity is one of the most important variables that a thermographer needs to understand. You need to understand how reflection and emissivity affect one another and how much they can affect the temperature readings you're getting. This does really underpin why it's important that you consider undergoing training. It's not just you can pick up a camera and you're a thermographer. You're not. You can look at infrared images and you can see hotspots, but when you're using those within your maintenance mechanism to ascertain when you can carry out repairs, you better make sure you're getting it right. So training is extremely important. Now, when the target emissivity is high, you can really trust the temperature measurements you're getting. So, for instance, using the tags or tape as targets will give you a lot of confidence that you have a known emissivity. However, You cannot trust what you're seeing when the material emissivity is low, because if the material emissivity is low, the reflection is high, and that reflection is significantly affected by the background temperatures around it. Incorrect emissivity has a significant effect on the accuracy of your temperature measurements. And the graph we looked at earlier, by going from 0.95 to 0.5, we've seen almost a 20% difference in the temperature measurement. So again, beware that you get the emissivity correct in your camera. Now, when installing infrared windows, we teach that you should basically standardize your target emissivities, etc., and record those emissivities on your infrared window tags, so then you'll know your targets that are behind there. You've identified and you've standardized your emissivity, you know the transmission rate of the window, so you're going to get good readings. So thank you for attending this webinar on emissivity. I hope you found it useful. If you'd like any more information on our electrical maintenance safety devices or training, please visit our website www.iris.com. Thank you and have a good day.